In this video, we are going to learn the method of completing to square. This is not actually a method for factorization of quadratic expressions, but this method helps us to draw the graphs of quadratic functions very easily. So we have to learn the algebraic bit. Now let's quickly remember what happens when I expand this perfect square. Well, this means x plus 5 times x plus 5, or which I would expand it like x times x squared, plus x times 5, 5x, 5 times x, 5x, and 5 times 5, 25. And then I simplify as x squared plus 10x plus 25. Now notice that the number 5 is doubled here, so this is basically 2 times 5, right? And this would be the same if I was to go with x minus 4, let's say. If I take the square of this, I would expand it as x squared minus 8x plus 16. 4 here is doubled, right? It's 2 times 4 here, 8. Right. So we are going to use this idea in this method. Now let's look at this one. What we actually want is to convert this into something like x plus or minus, maybe, it doesn't matter, x plus or minus a number a squared. So I need a perfect square, and then there could be a plus minus, I don't mind what that is, another number. What I want is a perfect square expression, so I have to convert this quadratic expression to a perfect square expression together with a number taken away or added. So this is the format that I'm going to convert it. So if a perfect square is involved, then I have to look at these two terms. This is x squared minus 4x. Now, what perfect square expression gives me these two terms? Now the key is that if you divide 4 by 2, you will get the answer. So if you go like x minus 2 squared, which would be x squared minus 4x plus 4, then you would get these two terms here. So that is the key. So first, we're going to start with dividing 4 by 2. 4 divided by 2 is 2. So I'm looking for x minus 2 squared. Fine. Let me expand this. X minus 2 times x minus 2 is x squared minus 4x plus 4 when you do all the work, right? And what I'm given is x squared minus 4x plus 9. Now, if I break 9 into 4 and 5, then I can consider this bit as x minus 2 squared. And then this expression will convert to a perfect square expression. It's going to be x minus 2 squared plus 5. And this is what I need to write. So first, I divide this number by 2 to find out what's going to be here. Then I expand this perfect square. So it's x minus 2 times x minus 2, which will be x squared minus 4x plus 4. And then I compare this perfect square expansion with what I have. I have x squared minus 4x plus 9. 9 is here, but I can break it into 4 plus 5. And when I do that, I get the perfect square expansion, which I can write the perfect square itself instead. And then I just have plus 5 here to write down. And this is what we call as completing to square. Let's see another example. In this one I have 2 here, so 2 divided by 2 is 1. So basically I'm after the expansion of x plus 1 squared, which would be x plus 1 times x plus 1, and it is x squared plus 2x plus 1. Now you have to notice that these two terms, the first two terms, are the same, right? This is what I want, actually. So now I have x squared plus 2x minus 4, but I want plus 1. So if I insert here plus 1 minus 1, as in, let's write that again, x squared plus 2x plus 1 minus 1 minus 4, right? I inserted this here. Plus 1 minus 1 means 0. Actually, I'm not changing the expression, but I'm trying to get what I want, which is this bit, because this is the same as this perfect square expression. So instead of that, x squared plus 2x plus 1, I'm going to write x plus 1 squared, right? This is what I want. And then I'm going to write down the remaining. It's going to be minus 1 minus 4, which is minus 5. So this is the answer. Now in this example, this number here is odd, but the method stays the same. So I'm going to go like 5 divided by 2. So I'm going to have 2.5. Now, I have to expand x plus 2.5 bracket squared, right? So this means x plus 2.5 times x plus 2.5. Sorry. Right? And yeah, this is a decimal there, but if you stick to the method of, expanding, it's not going to be a big hassle. So it's going to be x squared plus 2.5x plus 2.5x plus, well, 2.5 times 2.5 is 6.25. And you can see that these two like terms will simplify to x squared plus 5x plus 6.25. So this is my perfect square expansion. And notice that I have the first two terms the same. So what I'm going to do is I'm going to write down x squared plus 5x plus 6.25. Now the problem is my expression is not that. My expression is x squared plus 5x plus 3. Now how can I end up with 3? Well, I can take away 3.25, right? 6.25 minus 3.25 gives me 3. This bit. So this is 3, right? This bit is 3. So I can just write down, just because this is x plus 2.5 squared, right? I can just write down this expression as x plus 2.5 squared minus 3.25. This is perfect square expression for the given quadratic. So basically what I need is this perfect square expression, which these two terms should be the same as these two. And then I'm trying to adjust the last term, because the last terms do not match. I have 6.25 here, I have 3 here. So I have to take 3.25 away to make sure that I'm ending up with 3. I'm not changing this expression after all, right? So I find the perfect square which these first two terms are the same, and then I adjust the last term appropriately. That's what I do. In this example, you can see that we have a 2 here in front of x squared term. So it is easier to get rid of that. How? I'm going to take 2 as a common factor outside the bracket, so it's going to be x squared plus 4x plus 5. Now, I'm going to focus on this part to complete the square, but at the end, I'm going to include 2 in the beginning as common factor, right? I'm going to add that later on. So let's focus on now x squared plus 4x plus 5. Now, 4 divided by 2 is 2, so I'm after x plus 2 squared, which is x squared plus 4x plus 4. Again, notice that these two terms are the same. Now, I'm going to write this. You can see also the difference between the last term. So I'm going to write this as x squared plus 4x plus 4, and then to end up with 5, I just have to add 1 more. So this bit will be x plus 2 bracket squared, and then I have this bit remaining, so I'm going to write it as plus 1. Now, as a final answer, I have to include the common factor, so I should be writing this as 2 times x plus 2 squared plus 1. So the only thing that I have to do in the beginning is that to take 2 out, because I only know to complete to square when there is no number in front of x squared expression. So that's what I need to do. Now is your turn. Please solve these by completing to square and submit your answers online. Thank you.